Alright, this is our final lesson in this unit. It's going to be over arithmetic series.
And we the best markers.
Here's our vocabulary for this lesson. Series, when you say series instead of sequence, we're looking for the sum of the sequence. There is an infinite series and a finite series. Infinite means it goes on forever. Finite means it stops. And an arithmetic series, a finite series whose terms form an arithmetic sequence. So that's our vocabulary. Alright, so we have an arithmetic sequence here, 2, 4, 6, 8, and 10, and it wants us to find the sum of this arithmetic sequence. Well, this is a finite sequence because it has a start and an end, and it's pretty easy to do because to find the sum, all you do is 2 plus 4 plus 6 plus 8 plus 10, and all of that equals, 10, 20, it equals 30. All you have to do is add them up together. I got 10 here, plus 10 more, that gave me 30. So pretty simple, right? But guess what? It's not going to be that simple when we have a really big series of numbers where we don't have all of them. So here's our formula for an arithmetic series, and this formula also is on your reference sheet, so you don't have to memorize it. And just for ACT purposes, I don't really find it necessary to memorize this either, but we're going to be using it quite a bit. SN is your sum, A1 is your first term in this series, and AN is your last term. And N is always the number of terms you have. So make sure you write this formula down because we're going to be using it next. Alright, so here's our first example where we don't know all the numbers. So you can actually go and write it down and fill it in and figure it out, but it's going to take a lot of time. The easiest thing to do is, first of all, is to use your arithmetic sequence formula to figure out how many numbers there are. And from that, we can use our series formula to figure out the sum. So first of all, we want to know what term is this in this sequence. So we're wanting to find out what term, and that's our n, and that's going to tell us how many numbers there are. So 99 is what term in this sequence. So we play that in for an. This is our a of 1, first term always. We are adding 5 every time. So common difference of 5. We don't know that n, and as always, we subtract 1. So now it's just a simple equation where we distribute. We're going to distribute our 5. So you get 5n minus 5. Combine our like terms. So you get 99 equals 5n minus 1. Then you're going to solve this equation. Add 1 to each side. So you get 99 equals, whoops, I got to add a 1 to it. So it's not 99, it is 100. Equals 5n. Then you divide by 5. So we have 100 divided by 5, which is 20. So there is 20 terms total in this sequence or series. So now we can use our sum formula. Remember, it is n over 2, a1 plus an. Our n is 20. That's how many numbers there are in this sequence. Our a1 is our first number, and our an is our last number. Whoops. Which is 99. So all we have to do is take 4 and add it to 99, which gives us 103. And then we're going to times that 20 over 2, which is the same thing as 10. So the sum of this sequence is 1030. Or the series. This is a series, not a sequence. Alright, so let's see if you can use the two formulas and repeat what I did in the previous one. First, you got to find out how many numbers there are, so you're going to use the arithmetic sequence formula. And then you have to find the sum of that sequence after you know how many numbers are, and you're going to use the series formula. So pause the video and see if you can do this. Alright, here's what I got. I got that there were 10 terms, and the sum of this series was negative 165. If you got something different, we'll talk it over in class. Alright, this is our word problem from the last lesson where we had to find out how many seats were in the 16th row. So if you remember, we used the arithmetic sequence formula. Oops, common difference, n minus 1, to find out how many were in the 16th row. So row 16, we had 20 seats in the first row. We were adding 3 every time, and we were looking for how many were in the 16th row. And we got that to be 20 plus 3 times 15. 3 times 15 is 45, plus 20 is 65. So there was 65 seats in the last row. So to find out how many seats there were total, we're going to use the series formula. Alright, so the sum of this series is, our n is, how many rows did we have? 16. In the first row there were 20 seats, and we found out in the 16th row there were 65. So 20 plus 65 is 85, and we're going to multiply that by 16 over 2, which is 8. So there is a total in that section of 680 seats. Alright, so next you can actually write any series in what's called summation notation, or it's also known as sigma notation. And you will see this on the EOC, and you probably will see this on the ACT. So sigma, and this is our sigma here. It is a Greek letter, and in math it means to sum it up or add it up. And this is the format that our sigma notation is going to go in. We have the big sigma, and in the bottom we have our lower limit, that's our start value, and our upper limit, our stop value for our numbers. And then we're going to have our formula over here. And always the number of terms in a series is your upper limit minus your lower limit plus 1. Alright, so that's sigma notation. Now let's see if we can use it. Alright, so we have an arithmetic series here, and what we need to do is we need to take this series and we need to write it in summation notation. So if you'll remember, summation notation is our big sigma, and then we have our formula over here. And our formula is always going to be our sequence formula, our AN, and then we have our lower limit and our upper limit. Alright, our lower limit is our start value, and we always start with the first term. So when we do our sigma notation, we're starting with the first term, and we have to know how many terms there are. Alright, to know how many terms there are, we're going to use this sequence formula, and we're also going to use it to come up with our formula. So let's come up with our formula first, because I think that's the easiest. So here is our sequence formula. AN equals A1 plus the common difference times N minus 1. And we're going to plug that in there, that information. And first of all, we're going to get our formula. So our AN is our formula, so we're not going to plug anything in for AN right now. We're just going to substitute in our first term. And we are, let's see, adding 4, add 4, so our common difference is 4. And it's a formula, so we got to have a variable in there, so we leave that in there. Alright, so then we distribute our 4n minus 4. So our formula is, when we combine our like terms, 4n plus 3. So that's our formula that's going to go next to our sigma here. And let's see, now we need to know how many numbers there are. So now I'm going to take that in, and I'm going to substitute in for it 207. And I'm going to solve this equation for my n, and that's going to tell me my number that goes on top. They cancel out. 4n, and I have 204 here. I'm going to divide that by 4, and that's supposed to be a 4. So let's see, 4 goes into 25 times, and 4 goes into 1 times, so 51. So my top number there is 51. Alright, that's summation notation. Next, let's go to an example and see if you can repeat what I just did. So here's your problem for you to try. So let's see if you can repeat the steps that I did. So pause the video, give it a shot, and when you're ready to see if your outcome and my outcome are the same, restart the video. Alright, so here's what I got for my sigma notation, and actually I forgot to write. We're using the letter N in our formula. N equals 1. So at the bottom of the sigma on everything, it shouldn't just say 1, it should say N equals 1. Alright, so we'll be ready to work on arithmetic series in class. See you then.